Bismillahirrahmanirrahim. Let's learn how to differentiate the trigonometric functions. Okay, there are some rules that you have to remember to start with. Uh, First of all, we have to see that the derivative of sine x, that is going to be cos x, and then you have the derivative of cos x, that is equal to minus sine x, and then we have the derivative of tan x, and that is going to be secant square x. These are our three basic identities or the terms of the trigonometrical ratios that we have in trigonometry. So if we know the derivatives of these sine, cos, and tan, then we can differentiate any expression, any trigonometric expression or function. Okay, so let's see. For example, if you have y is equal to sine x plus 2 cos x, so its derivative would be cos x minus 2 sine x. Okay, suppose you have y equal to um, tan, let's say 3 tan x minus 4 sine 30. Okay, so the derivative would be 3 secant square x. And now you see this is sine 30. If you, for example, you differentiate this as it is minus 4 cos 30, and then there has to be, like, obviously this 4 sine 30 is a number, like, 4 sine 30 is half. This is basically 4 into half, so that is going to be 2. So you have learned this, that the derivative of a number, if number is a 0, so this should be 0. So the rule is that when you're differentiating a trigonometric function, you're basically, you when you differentiate this sine x, you write it as equal to cos x times 1. There is times 1. Now, what is this 1? This 1 is basically the derivative of the angle x. Okay, if your angle is x, so you have to write times 1 with this. Suppose if you were differentiating sine 2x, this will have to be cos 2x times 2. So we write that 2 in the beginning over here. Suppose you have to differentiate tan 3x. So its derivative would be secant square 3x times 3. So this way, when you are going to differentiate this 4 sine 30, so yes, you write this as 4 cos 30, and then there has to be times 0, which makes all of this term 0, and you're only left with 3 secant square x. Okay? If I relate this with the exponential functions or the logarithmic functions, so there you have seen that uh, like if you differentiate e raised to power 2x, so that is e raised to power 2x times 2, that is the derivative of the power. Similarly, if instead you have to differentiate simply e or e square or e cube, so this derivative has to be equal to 0, because when you multiply this, for example, there is 2 over here. Okay, so this is e square times this 0, that is the derivative of 2, so this becomes equal to 0. In the same way, when you were differentiating the logarithmic functions, if you have ln, let's say x squared plus 1, so this was 1 over x squared plus 1 times the derivative of that x squared plus 1. If instead you have to differentiate ln 5 maybe, so when you write this as 1 over 5, so then there has to be the derivative of 5 over here. So this makes it 0. So the very first instance, you can take this as a constant. So the derivative of a constant is 0. This is also a constant. So the derivative, this is the number. Both of e square and ln 5, they are representing the numbers. Similarly, in your trigonometry, if you're going to suppose you have to differentiate this tan 45, okay? So tan 45 is itself a number. But if you want to differentiate this using the trigonometrical principle. So first of all, you will write it as secant square 45, and then you have to multiply it with the derivative of this 45, so which will make this equal to 0. So if you have seen these three rules over here, the derivative of sine x, cos x, tan x, you can rephrase these rules over here by saying that their second version basically, uh, there will be three versions for this. The third would be the final one. So I can tell you the third at once. So next you have that if you have to differentiate sine with the composite angle, okay, so this has to be cos ax plus b times the derivative of the angle, okay. If you have to differentiate this cos ax plus b, this has to be minus sine ax plus b. Remember this minus from cos to sine. So this a is the derivative of ax plus b. And then for the tan, you have tan ax plus b. So this will be a secant square ax plus b. Okay? If you know these rules, then we can try some questions from here. Now look at these questions here. Um, we can quickly find their derivatives. Now, what is the derivative of 2 plus sine x? Yes, Walid, you will have to be very quick here. I want to cover this today. Yeah, the derivative of 2 plus sine x. Hmm? Yes, Walid, hurry up, yaar.
Sir,
What is the derivative of 2? Hmm? The derivative
sir,
of 2
nothing.
is nothing, 0, okay? So then
Zero.
what's the derivative of sine x? Hmm?
One.
Cos x. The derivative of sine x is cos x. Okay. Now, uh, tell me about the b part. 2 sine x plus 3 cos x. Yes. The derivative of 2 sine x
Uh,
is
Sir, two
2
cos
cos.
x.
Yeah. And plus 3 cos x derivative is going to be
Minus three sin x.
very good. Excellent. Excellent. So this is 2 cos x minus 3 sine x. Now tell me about the c part. Mhm.
Sir, minus two cos x. Or
Minus 2.
minus two sin x.
Yeah.
Minus secant square
Minus
x.
secant square x. Very good. Okay. The d part. 3 sine 2x. Yes. 3 sine 2x.
Sir, six cos two x.
Very good. Shabash. E part 4 tan 5x.
Sir, 20 secant
Uh-huh.
square 5x.
Very good. Mashallah. F part. Mhm.
Sir, minus 6 sin 3x.
Shabash.
Minus 2 cos 2x.
Very good. Very good. Very good. Good going. G part. Mhm. G part.
Uh,
You see the angle is 3x plus 2.
sir,
Yeah, 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 yes,
sir,
yes.
3x secant square.
No, no, 3 secant square. 3 secant square. 3. You will write it like this. Secant square. The angle would remain as it is, okay? And times this 3. That is the derivative of 3x plus 2. This is 3 secant square 3x plus 2. Got it?
Yes, sir.
Yes. Okay. Now H part.
Sir,
2
2 cos
uh, 2x plus pi by 3. 2 cos. So you will
2
write it like
plus
this.
pi by 3.
Yeah, this would be written as 2 cos 2x plus pi by 3. Okay. And this I part.
Minus 2
Uh-huh. Minus
uh,
2 sine. Sorry, minus 6 sine.
minus 6
Minus 6 sine.
minus 6 9 3x minus pi by 6.
Oh, okay. So you see this is like we started with simply differentiating sine x, cos x, and then tan x. And then we differentiated, we have differentiated from the part D onwards, the trigonometrical ratios with the composite angles. Now you look at the second question. You see that now these trigonometrical ratios, they have got powers on them. Well, let's see how to differentiate in such cases. That is the third and the final version of this trigonometrical differentiation techniques. Okay, now we started by saying that d by dx of sine x, that is cos x. Then we said, okay, if we have to differentiate sine ax plus b. So that would be a cos ax plus b. Remember, don't ever do anything with the angle when you're writing from sine to cos or from tan to secant square or from cos to minus sine. The angle remains as it is. Now we have the powers on these sine, cos, and tan. When we talk about the powers thing, so remember, we'll deal the same way we have been dealing with the algebraic expressions. Remember, if you had to differentiate that x square minus 1 whole cube, let's say, so that was 3 into x square minus 1 square, and then you had this 2x, that was the derivative of the expression that had a power, like which was x square minus 1. Okay, so first you deal with the power here. So you differentiate the power and then you differentiate the base over here. In the same way, if I can make you recall, for example, if you have to differentiate, let's say there is ln x, it is only ln x and there is a square on it. So this would be 2 ln x. Now that is a power thing, 2 into ln x. And then ln x had the power. So that is going to be 1 over x and times 1. That is the derivative of this x. Okay? Now similarly, suppose if you are required to, let's say you have to differentiate um, um, sine cube 2x. Let's say you have to differentiate sine cube 2x. So man, look at this. You will write this as, first of all, 3 sine square 2x. This is 3 sine square 2x. Okay? The power 3, and then 1 minus from the power, this becomes 3 sine square 2x. Then you have cos 2x. That is the derivative of the one who had power, okay? And then you have times 2. So this is basically the power, the base, and the angle. This is called the power base angle method. So whenever you have the trigonometrical ratios, so I mean, this is the final version for that. Like if suppose you have to differentiate um, cos raised to power 5 and the angle is 2x plus pi. So this will be, you see, this will be 5 cos is for 4 2x plus pi. So first you deal with the power, and then there is going to be minus sine 2x plus pi, and then finally into 2. So this is 5 into cos to the power 4, blah, 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 times, now the derivative of cos is minus sine. And then at the end, you multiply with the derivative of the angle. Now let's see at these questions here. Now you have here sine cube x. I'll do them quickly for you first, and then you will try them. Sine cube x is basically, it will be, let me cover this area so that I can have some space here. Okay. So I'll mix them up so that you can't, when I'll ask you, you can't see it from here. So sine cube x is going to be 3 sine square x cos x times 1. So I'm not writing that one. So Walid, do you see the derivative of sine cube x is 3 sine square x cos x. Now you see the derivative of the b part, the b part. This will be, I'm writing this minus because I know that the cos derivative is going to be minus sine. So this is 10 cos 3x sine 3x times 3. So this is eventually minus 30 cos 3x sine 3x. Okay. Then you have the c part. It is sine square x minus 2 cos x. Now sine square x is going to be 2 sine x cos x. And then you have plus 2 sine x. Okay? Now the d part should not be a problem for you. In this d part, this is quite simple. This is 4 into this 3 minus cos x raised to power 3 into 3 minus cos x derivative is sine x. That's it. Okay. Then you look at this e part. It is going to be 6 sine square 2x plus pi by 6. Then you have cos 2x plus pi by 6 times 2. This is finally 12 sine square 2x plus pi by 6 cos 2x plus pi by 6. Okay? And then the last one, that is going to be 12 cos cube x. Then there is a minus sine x. Okay? And then you have plus 4 tan 2x minus pi by 4 secant square 2x minus pi by 4 times 2. Okay, and then you can simplify. This is going to be minus 12 cos cube x sine x plus 8 tan 2x minus pi by 4 and secant square 2x minus pi by 4. Okay, can you try these now? So that is how you were differentiating the parts of the second question. If you look at the parts of the third and the fourth questions, you can see that it's only about identifying that there are cases where you go for the product rule, the quotient rule, okay? And you have to take care of these rules. And similarly, if you look at the fourth question, so there are the exponential and the logarithmic things. You see e raised to power sine x derivative, e raised to power sine x derivative will be e raised to power sine x, and then times it will be cos x, because the derivative of sine x will be cos x. Look at this ln cos x derivative. This will be first of all 1 over cos x. Okay, remember the logarithmic differentiation. And then you have minus sine x. Okay, you try the all the parts of this question number one, two, three, and four. And then, inshallah, we can discuss these questions tomorrow again. Okay. Try all these parts of these four questions. And then, inshallah, we'll go beyond this tomorrow. Okay?
जी सर.
Okay, then Allah Hafiz.